Good afternoon, everybody, and welcome to today's webinar. My name is Cheryl Jennison DeProsa, and I am joined today by Gino Sigismondi. And today we're going to sit down and talk with product manager extraordinaire John Bourne. Excuse me, the afternoon. Woo! And we're going to be talking all about Unidyne technology and how that leads to Dualdyne technology. What is Dualdyne? Well, you're going to find out a little bit later today. But before we get to that, just a few items of housekeeping. First of all, this webinar is being recorded. So if you ever want to go back and watch it again or direct a colleague to it, you can go to shure.com/training. That is where all of our webinar archives are kept. This one will be available probably sometime early to mid next week. There's also all of our past webinars linked there. So there's a ton of great learning across a lot of different topics. So please feel free to peruse that site and learn a bunch of important good stuff. Secondly, as we go through today, if you have any questions, please feel free to type those into the question pane. You should see a little sort of box on the right-hand side of your screen. If you don't see it, look for a little toolbar with an orange box with a white arrow on it. Click on that. That will maximize that pane. Enter any questions that may come up in your head, and we will get to as many of those at the end of the session today as we can. So that wraps up all the items of housekeeping. I'm going to pass it over to John and Gino. Take it away, guys.
All right, thanks, Cheryl. Thanks, John, for joining us this afternoon.
Thank you for having me.
So if you couldn't guess from the title, we are talking all about dynamic microphones this afternoon with today's webinar, which is going to culminate in some very exciting new dynamic microphone technology, which is not something that anyone's really been able to say for a long time. As you'll see, as we kind of trace the history of the unidirectional dynamic microphone, of which, Shure has kind of played a not insignificant role in the development of, for a long time, kind of seemed like we'd kind of reached the pinnacle of that technology. But turns out there was still some optimization yet to be done, and we'll see what that is with the Dualdyne. So I'm going to pass it over to John and let him start telling us about
the Unidyne and the Dualdyne.
The Unidyne and the Dualdyne.
Yeah. So thanks for having me, guys. We're gonna touch base, kind of a little bit historical relevance on what a dynamic microphone is, our role at Shure in the dynamic microphone history, and then kind of where we are today with the Dualdyne and what makes that product special, and the KSM8 and that element. And kind of the big benefits we're seeing in the market already about what the Dualdyne really is about. Do a little quick refresher on what the dynamic microphone is. And we've had, here at Shure, we're really fortunate enough to have an amazing mic lab, is what we call them. They're all the acoustical engineers. They sit down in the mic lab where they can pretty much make anything from scratch. And over the last over the last 90 years, we've developed brand new transducers to the world, whether that's earphones or headphones or microphones, or technically antennas and wireless products are all transducers. We make transducers. We're a transducer company. We design new, innovative transducers for the world. And the KSM8 and the Dualdyne element is just another one of the new transducers that are on the market now. And we've done that for a long time. So we're really good at taking acoustical energy and turning it into electrical energy, and no matter whether that's in a condenser mic or a ribbon mic or a dynamic mic. But today we're going to talk about dynamics. So there's major components of a dynamic mic are the diaphragm, the magnet, and the coil. The diaphragm is normally a formed piece of mylar in a shape with a dome. There's normally ridges cut out to keep it stable. Attached to that diaphragm is a coil. It's normally made out of copper or copper-clad aluminum, and it's a wound coil, just like a voice coil in a speaker, that's attached to that diaphragm, and that is suspended around a magnet. And it doesn't touch the magnet. It doesn't touch the pole piece either. It's suspended in what's known as the gap. And there's a magnetic field created by the magnet, of course. And the pole piece is basically a ferrous chunk of metal that the magnet sits in and directs that magnetic field towards the coil. So we can saturate as much of that magnetic flux, is what we call it. And we want to saturate as much of that magnetic field as we can towards the gap where the coil resides. And as sound strikes that diaphragm and coil, it moves that within the magnetic field, and a voltage gets applied across that coil. And in many cases, we literally take those coil leads right off the coil and send them to your XLR connector. And that is the basis of all dynamic mics. It's very simple in its theory, but it is really difficult to implement because you don't have circuit design, you don't have EQ circuits or phantom power, or you don't have a get out of jail free card on a dynamic mic. You have to design the diaphragm and the magnet and the coil to get the response and the output level and the sensitivity all within you versus physics on that. So it's very easy to make a dynamic mic, but it's very hard to make a dynamic mic that sounds good, that is flat sounding, that has good output level, that is robust, that is consistently the same every time. And that's what we do really well here at Shure.
Because you could take a loudspeaker and turn it around backwards and essentially make that into a dynamic microphone.
Yeah, you can drive the headphone out on your headphone amp and poke it up to your microphone, and your little dynamic mic can become a really bad sounding speaker, and drive it in reverse. But it's really the shape of that diaphragm and how that interacts with sound as it impinges upon it, and how that magnetic flux is directed. And we use a lot of innovative tools at Shure, model simulations. We write a lot of simulation programs to predict all these things acoustically and electrically. But as we went through this KSM8 project, it's both a little bit of that and a little bit of just let's slap something together with some glue and rubber bands and tape and see if it makes noises, that are worth anything. So here's kind of how the dynamic mic. We have a lot of animations in this slide deck today, so it helps kind of convey all the differences between our dynamic mics. So here's how a basic dynamic microphone works. You have a diaphragm, a coil, and a magnet. Sound strikes that diaphragm, it moves that coil within that magnetic field, and we literally take that voltage off the coil and send it down your XLR connector. Occasionally there might be a transformer involved to improve the impedance output or the sensitivity, but at its core element design, it's those three things.
And since there's not a whole lot of components in there, I mean, as far at least compared to some other electronic devices, it's relatively inexpensive, at least as compared to some other types of microphones, particularly some high-end condensers and ribbon microphones. Is really relatively inexpensive, and again, also very rugged and reliable. I mean, dynamic microphones are typically known as the most rugged microphones you can get, yet still sounding, really good, for a whole wide variety of applications. So there's some definite advantages to it.
Yeah, and condensers and dynamic mics have their role in throughout the audio industry, and dynamics are known for their ruggedness. They sound great, but there are some inherent things to the dynamic microphone that the KSM8 challenges, related to its response and what it can do and how good a dynamic mic can sound. But the biggest benefit, I think, personally, of dynamic mics is just they're much less sensitive than a condenser microphone is from a audio capture standpoint. They're a safer choice for stage use because they're less prone to feedback than a condenser mic. The KSM8 kind of helps in that respect, where you get this great sound quality in a condenser, that why people love condenser mics, but you get it in a dynamic package, being less sensitive and less stage bleed and all those great things that people love about the safeness of choosing a dynamic mic.
And that's one of the things that, in the past when we would do seminars on microphones and the differences between dynamic and condenser, we would always tell people, if you want a condenser microphone, if you want the most natural sounding microphones, you should always go with the condenser microphone, because the dynamic microphone is just generally not going to be as, able to achieve that same kind of frequency response. But again, that's one of the impetus for the development of the Dualdyne, right, and which we'll talk about later, again, is how that newer technology allows that dynamic microphone to have a frequency response that is closer to what you might in the past only been able to achieve with other technologies. Yeah.
Mm-hmm. So a little bit history lesson, the Unidyne elements. So the Unidyne was the first single element directional dynamic microphone. We designed it in 1939. Benjamin Bauer, the inventor of the Unidyne element, the Shure engineer. When it first was realized in the Model 55, which is a very recognizable product to many of you. And what was special about that microphone is, it created a cardioid puller pattern utilizing one element instead of two. Prior to this invention, you had to use two elements and combine the outputs of basically a bidirectional and an omni, and try and get some sort of directional pattern out of the microphone. And it was clunky. It didn't work too well. It was expensive. It was fragile, and there really wasn't a very good intelligible microphone that could be amplified and not feedback, basically. And the Unidyne, the Model 55, changed that. That was the catalog, the goodbye feedback from our catalog in 1939. And the Unidyne and the Uniplex at the time were the remarkable inventions by Shure engineers that changed audio forever, basically. Every directional dynamic microphone in the world made by anyone is based on our patent from 1939. And that patent is the basis for creating a directional microphone in a dynamic mic. And we patented it, so we did pretty well for 15 years while this patent was active. And it was it really changed roller rinks and supper clubs and supper halls all across the world. And really was the basis for all of our dynamic microphones going forward. And the uniphase principle is what is inside of the Unidyne microphone, and that is what creates rejection utilizing one element. So the way we create rejection, oh, and by the way, we got an IEEE award on this, which was really remarkable. We're in the same category as the invention of the laser and the telephone and the resistor and the silicone chip and sending somebody to the moon and to be part of this the internet, like the IEEE milestone, the IEEE organization awards the milestone award to inventions that have benefited humanity, and for it to have the 55 and the Unidyne as part of that list now that was a special day at Shure when we were presented that award. So the Unidyne element is still made today, and many of its theory and its principles are throughout our portfolio today, and we're pretty fortunate to have that in our catalog. So what makes the Unidyne element special is we created rejection. We created a unidirectional microphone utilizing one element, and the way we do that is we allow sound to strike not only the front of the diaphragm but the back of the diaphragm as well, and we delay that sound just a little bit. And here's the animation that we'll show you here. So sound comes and strikes the front of the microphone and moves the coil and diaphragm as it would, but sound coming from behind the microphone actually gets delayed a little bit before it strikes the back of the diaphragm. And that delay time is set to the same amount of time it takes sound to actually wrap around the microphone and hit the front of the diaphragm. Sound strikes the front and the back of the diaphragm at the same time, and that diaphragm doesn't move. It cancels out. And that's how we get rejection. That's how everyone gets rejection, basically, in a dynamic mic. I'll play that again one more time. And this is the uniphase principle at work in the Unidyne microphone, which makes us have rejection in a mic.
I kind of think of it as if you picture like a swinging door, like a kitchen door in a restaurant that swings both ways. And if someone's trying to go in and someone's trying to go out and they're both pushing on the door doesn't go anywhere.
Yep.
Right? So that's what's going on here. And it's interesting because it's sort of, I think, counterintuitive to what most people would think. Would be like, well, if you didn't want pickup from the back, wouldn't you close off the back of the microphone? But that actually makes a microphone omnidirectional when you do that.
Yeah.
So
If you want an omnidirectional mic, you just close off the back, and basically through the process of diffraction, anything that's around that microphone will imping upon the front of the diaphragm and cause it to move. So that's what happens when you cup the grill of the mic. You basically close off that entry port into allowing sound to strike the back of the microphone and back of the diaphragm. And by closing it off, you kind of make it a really bad omnidirectional mic.
Or when you wrap gaff tape around the grill of your SM57.
Yep.
Right?
Yep. Any directional mic will have what's known as side entry ports or rear entry ports, and it may be under the grill or hidden behind a screen or something. But to make a directional mic, you need to allow sound to strike the back of the diaphragm, and the Unidyne element was the first to do that. So. Moving on into the history lesson here, in 1951, we came out with the Unidyne II element, so an improvement on the Unidyne. And at that point, TV was starting to come on board, and the Model 55 is the fat boy as we know it, was fat. And it was a little too big for TV, so we slimmed it down, came out with the 55S. S stood for small, and the small Unidynes, and we improved its acoustic properties in that process, and basically all the benefits of the Unidyne in a smaller package. And the 55S and the Unidyne II element was really instantly recognizable as the microphone that needs no name. And you have an emoji on your iPhone now of the 55, which is pretty cool that Apple did that. And you can send, when you think microphone, you probably picture this in your head. You either probably picture this or you picture an SM58. And we'll talk about that design in the next slide of what makes that special. So the 55S we still make this product in this form today. We have a couple versions, a Super 55, the 55S Series 2, and then if you're fortunate enough, you could get a 5575 LE, which was the reissue of the Fat Boy since we celebrated its 75th anniversary a year or two ago. So. And then moving on to 1964, another big product launch in dynamic microphones for us was the Unidyne III element. And this was developed by an engineer called Ernie Sealer. And he challenged the microphone, the dynamic mic, to really put it in an end address form factor, which had never been done that we know of. But the biggest problem that dynamic microphones have is they want to capture vibration. They are designed to capture vibration, whether that's acoustic vibration or whether that's mechanical vibration. And they are perfect accelerometers to do that. And dynamic mics have normally a lot more prone to handling noise than a condenser microphone is. So you have to have a pretty elegant shock mount inside a dynamic mic. And Ernie Sealer designed what we know as the pneumatic shock mount, and it was built into the handle of the 545 and the 565. And the reason why it's so special is because it is part of the acoustic network of the mic. So it's actually vented. The pneumatic shock mount is actually vented as part of the microphone's design. You can't just design the microphone and then put a shock mount around it. They have to be, since they're related, they have to be done in parallel together. So the 545 came out, and it was the first time you could truly take the microphone off its stand and hold it in your hand and not get unusable amounts of handling noise. And it allowed the user to run around on stage. The 545 did. And with that, though, came some challenges of plosives. We had microphones that were a lot closer to the mouth now, and we had, which helped with gain before feedback, but we also had all these plosives and wind noise we had to deal with. So a few years later, we came out with the 565. And the 565 was basically the 545 with this self-windscreen, quote-unquote, ball grill around it. And it was the first ice cream cone-shaped mic. And that's pretty ubiquitous now, the ice cream cone-shaped microphone. And the 565, not only did it allow you to finally get the microphone close to your mouth and hold it in your hand and everything, but it also cut down on plosives and wind noise and was really those two microphones, the 545 and the 565, were the predecessors to the SM57 and the SM58. So we're fortunate to be celebrating 50 years of the SM58 this year, which is pretty remarkable to have a mic.
Still the world's best-selling microphone.
Still the world's best-selling microphone. And it's pretty awesome to celebrate 50 years of the 58 this year. So I think
of any 50-year-old product that's still the best-selling product in its category.
Yeah, it's pretty unbelievable. We're still scratching our heads how that is, but we're taking it for sure. So the SM58, the self-windscreen, unidirectional dynamic, and allowed you to run around on stage with a microphone in your hand, which hadn't been done before this time. So really, not only did it change, the performance of the dynamic mic, but truly changed how artists interact with audiences, giving them that freedom to do that. So that was in 1966, and that was the Unidyne III element. And that kind of brings us up into where we were a few weeks ago prior to the KSM8, where almost all of our designs of dynamic microphone designs are based on the Unidyne III in some way, shape, or form. And virtually all dynamic microphones in the world are based upon the Unidyne, original Unidyne. So that's kind of where we have been for the last 50 years.
There was some minor differences, like the introduction of neodymium magnets in dynamic microphones, and different, refinements of the, going from cardioid, supercardioid, and hypercardioid, polar patterns, and sort of, some minor revisions of basically updates to basically the same principle.
Yeah, the theory, is basically variations on a theme, and we can put a different magnet or tweak the coil or tweak the diaphragm, but they were all based upon the theory of the Unidyne III. And by the way, we got a patent on the Unidyne III as well. Thank you, Ernie Sealer, for that one. Charles E. Sealer, that is, technically. But he patented the Unidyne III element, which had the pneumatic shock mount in there, and that was 1966, that was. So another patent in our file. And I'll show you real quick how the Unidyne III works, so with the pneumatic shock mount. So in its end-address form factor, sound still strikes the front, and still sound from the behind the mic still cancels and strikes both the front and the back. But then sound actually goes through the microphone's element down into the handle. And down on the handle of the 58, there's a cavity of air and a couple pieces of very specific compliant rubber. And basically the whole cartridge sits on top of a pneumatic system, on top of a pocket of air. And as sound strikes the diaphragm and goes down into the handle, as you create vibration by holding the microphone, that vibration basically changes the volume of that pocket of air in the handle. And that cartridge, that pocket of air gets smaller and actually forces more air up into the cartridge. And it stiffens that diaphragm and coil assembly as you're inducing that handling noise upon the mic. And as you stiffen that diaphragm and coil, it basically prevents it from moving while you're exerting your handling noise upon the handle of the mic. And it requires about 300 pages of math to figure that out. And then it requires a whole bunch of time and effort to execute that math within actual parts and have it actually realized. So that's what makes the pneumatic shock mount so special is, the theory of the pneumatic shock mount is out there and how to do it. But the implementation of that in real parts with a specific grade of rubber and the particular weight of the cartridge and the compliance of the diaphragm and the specific resistance and volume of air you need to have that system all work. Because if one of those things kind of drifts a little bit, the whole system falls apart. That whole pneumatic shock mount system falls apart. And you actually are worse off than just hard mounting it. So it requires a really, really solid, stable, and consistent supply chain. It requires, we basically hand tune, not hand tune, but robotically tune every shock mount to a particular resistance to set that value. So it's pretty special, and it works extremely well. We wouldn't go through the effort if it didn't work that well, but it frankly is the best way to shock mount a dynamic microphone.
And I point out that, again, that's one of the differences that people often overlook between a professional microphone and an inexpensive microphone is how good is the shock mounting. You might find a microphone that looks a lot like an SM58 and you pick it up, maybe talk to it, maybe it even sounds pretty good, but then give it a good couple smacks on the side with your hand while listening to it and hear how much noise it makes, and you'll notice, then you'll appreciate what the pneumatic shock mount does for you.
Mm-hmm. And we have a pneumatic shock mount design in many of our handheld dynamics, the whole beta line, the whole SM line, except for the even the SM48 actually has a somewhat of a pneumatic shock mount in there. So yeah, they're used throughout our portfolio. All right. So that brings us to today. 2016. A couple of weeks ago, had a big splash at the NAMM show, and we introduced the world to this brand new transducer design and microphone, the KSM8 Dualdyne. And the KSM8 Dualdyne is the world's first dual diaphragm dynamic handheld mic. It utilizes a single element design, but utilizes two diaphragms within that single element. And we challenged ourselves 7 years ago. We challenged ourselves and said, how can we improve the dynamic mic? What is the next problem we need to solve? The original Unidyne solved, this feedback issue everybody was having. Unidyne III solved this handling noise issue everybody was having. And the next big thing was we asked ourselves, well, what's the next thing we need to solve? And it came down to proximity effect. So the proximity effect, we'll talk about deeply about what that is, but it's basically the buildup of bass response as you get closer to a directional mic of any type, whether condenser, ribbon, dynamic. But as you get right on the grill of a dynamic microphone or a directional microphone, it gets muddy and it gets warm. You get a couple inches off and it might sound nice and balanced, and then you get too far off and it's kind of thin sounding and you're fighting to get more low end out of the microphone. That's called proximity effect. It's physics. There's no real way around it, kind of until now. And what that results in the engineer and the user basically having a really limited sweet spot on the mic where it sounds natural and nice. And it results in the engineer applying a lot of processing and EQ to counteract those changes as a user might get further or closer away from a microphone. And the KSM8 Dualdyne, we wanted to challenge ourselves, how can we control that more? How can we give the user a huge sweet spot? So we went back to the drawing board. We went back to the lab notebooks about 7 years ago. We went through all the lab notebooks of Ernest Seeler and Benjamin Bauer, and we had to really kind of relearn what makes the Unidyne III mic special, because we hadn't really done a new dynamic transducer in, frankly, 50 years. I mean, the beta line was 25 years old at least now, and that was kind of a variation on a theme, but it's been we knew how to make it all day long, but we really didn't know the essence and the core acoustical reasons on what makes the Unidyne III special. So our engineers went back through the lab notebooks and really learned at its core what makes the Unidyne III element, what's the special sauce in it. And they stripped it down, and we knew from our KSM9 that if we could get a second diaphragm as part of the resistance network, as part of that side entry network of how to create a directional mic, if we could fit a second diaphragm in there, we could control this proximity effect. The challenge was on a dynamic microphone, how do you physically do that? Because you got all this stuff in the way. You got a coil and a pull piece, and you need these cavities of air that you need to have in there to control the tune-up. But we knew if we could kind of do that, we could control proximity effects, and we did. And that's kind of why it took 7 years, because you break a lot of things when you try stuff like that. And you spend all that time fixing all the things that you break. We realized three main benefits out of this KSM8 Dualdyne. So it has a second diaphragm as part of the acoustic network. And that second diaphragm, we'll talk more specifically about how it works and why it works the way it does. But it gives us three big benefits. We get a huge sweet spot on the KSM8. I'm speaking about 4 or 5 inches away from the mic right now, and there's probably a decent amount of low end still. That's the huge sweet spot we're talking about. I can get right on this mic. I'm right on the grill of the KSM8 right now. By the way, I'm speaking to all KSM8s here in the webinar room. And I get further away, and you might hear volume changes, but you're not going to really hear tonal changes. And that's really what makes the KSM8 special, is that huge sweet spot on the 8. And we get that because we're controlling this proximity effect.
I think it might be worth pointing out, just so that people are totally clear on what we mean by sweet spot, is we are, again, talking about that distance between your mouth and the microphone. Sometimes people think a sweet spot is like getting off to the side, right? Mm-hmm. So it's still a cardioid pattern in terms of its angle of acceptance, in other words, but shouldn't be taken to mean that, if I move way off to the side here, I'm sure everyone can hear the level difference versus when I'm right in front of the microphone. So again, we're talking about front to back controlling proximity effects so that your low end stays consistent. That's what we mean by the sweet spot. Right?
Yep. We've actually designed probably the flattest frequency response dynamic mic we've ever done. Well, we have, not probably. It's got the flattest top end response, which really results in minimal EQ and processing, especially in the higher frequency range. We'll talk about why that is in the next slide. And then we also wanted to have a really, really clean, pretty much the best cardioid pull-out pattern we've ever done. And that results in extremely natural stage bleed. A microphone needs to sound good not only on axis but off axis, and we knew that was important. So when you design a microphone from the ground up, from nothing basically, the engineering team said if we want to do this, we can't be beholden to an existing part or an existing process. Everything has to be new. We need every lever at our disposal to tune and make this microphone a reality. And there is literally nothing reused in this mic. Every single part and process and the way we even got there is brand new. It's a totally new production line at Shure. It doesn't share any other parts or processes with any other dynamic mic we make. And that was really that was required to bring something this innovative to the market. So here's a quick demonstration on proximity effect. So it's that buildup of low frequency response as you get closer to a directional microphone. And we got a patent, Side note, we got a patent on this. Hey, go us. So we were issued a patent in 2014 on this Dualdyne design, and got to work with those really smart engineers who helped do that. And it was actually the fastest we've ever received a patent. Patents normally take at least 3 years to really get issued. This one was under 2 years, and it was the fastest we've ever had issued. So it kind of just shows how innovative this transducer design really is, and it really didn't trigger anything else out there that would be challenging it. So that's pretty cool. And that has to do with this reversed airflow. We had to reverse the airflow to fit this second diaphragm in there, and we'll talk about how we did that. So here's a little demonstration on proximity effect. You're singing on the mic, you get really close to it, you get this big buildup of low frequencies. You get a little bit further away, it sounds nice and balanced, and then you get too far away and it really is a lot thinner, and you're fighting to get more low end out of the mic. That happens naturally because of the proximity effect. And it kind of limits the user into really having a nice, consistent sound quality. You'll find this, the more of a presence peak you have in the mic, or the less of the low end you have in a microphone, you'll find that sweet spot is even more limited in its pickup. So the KSM8 sweet spot is pretty huge. Here's a little demonstration on the KSM8. You get right on the KSM8. It tames that second diaphragm, tames that proximity effect just enough to kind of keep it in check. And you're not going to get a really big buildup of bass response on the KSM8. And you're not going to get a really, really thin sound quality as you get further away on the KSM8 as well. And that really results in just a lot less EQ and processing for the engineer to do. So the summary of that is, it doesn't get muddy, it doesn't get thin. You get this huge sweet spot that you really don't find on other microphones, and increases that working distance as we say. That's because we control that proximity effect. The response on this mic, I said it's the flattest response we've ever made in a dynamic mic. That's because we built this thing from scratch, and we had every opportunity to tweak and dial. And as I said, on dynamic mics, it's you versus physics. So it has to do with the shape of the diaphragm and the resistance parts and the resistance values and the cavities of air, and it's basically you versus physics on physically damping down that presence peak that you find on dynamic microphones. And we could do that because we have the ability to do that because we're controlling proximity effect. So the reason why this presence peak is in these microphones is because you want to still have an intelligible microphone when you get right on the grill of it. So you have to kind of boost those frequencies to counteract the muddiness you get. Because we're controlling that proximity effect, it gave us the ability to not have to have such a strong presence peak. So here's the response of the KSM8, much flatter in the top end response, and that just equals less EQ, less processing for the engineer to do, especially in that 5 to 8K kilohertz range, where you kind of get that de-essing and all that sibilance. So it doesn't sound like any other dynamic microphone out there. And then we also wanted to make the best sounding cardioid mic we've ever done, because we had every opportunity to do that in the process. We could tweak and tweak and tweak and tweak and tweak. And you may have so the polar pattern, defines how that microphone picks up sound at what angle, right? So cardioid is a very, very common polar pattern, a unidirectional polar pattern. And it picks up sound from the front and rejects the most from the rear. Supercardioid, for instance, would be even more rejection on the sides. Hypercardioids, even more rejection on the sides. And we wanted a textbook cardioid, and we pretty much got it. Not only is it cardioid at 1K, but it's cardioid at 6.5K and 300 hertz. And that's really important because as instruments bleed into the microphone when you're on stage, you want those instruments to sound like instruments. You don't want the drum set to sound like a drum set through a tin can or a paper bag, or the guitar amp to sound like it went through to be all nasally sounding. Because then you're fighting to EQ that bad sounding bleed out of your microphone. And that's probably one of the biggest things we've heard over and over with our testers and the field research is, it sounds so good not only on axis but off axis, and that's equally important. So when people ask me, does it have more rejection than a Beta 58 or an SM58? It has about the same amount of rejection of an SM58, but it's not necessarily about how much rejection you get, but it's the quality of that rejection. And the quality of the rejection on the KSM8 is pretty amazing. And that's apparent whether it's in an in-ear mix, a singer singing into your in-ears notices it immediately. Stage bleed at the front of house going into your vocal mic notices immediately. The front of house engineers notice it. And when you look at the sound quality of the KSM8, and people love condenser microphones because they have a really flat, smooth top-end response. But you're plagued with overly sensitive condenser mics, so with stage bleed and stage wash, and a lot of high-end condenser users have already switched over to the KSM8 because they get that really smooth top-end clarity that they love in condensers, but they get this in a dynamic package where it's less sensitive, there's less stage bleed, and it's really changing the perception on how good a dynamic mic can be. James Taylor's been using it. David Morgan, the engineer for James Taylor, has been using it for the last 6 months, and it was his dream come true. Basically, he told me, he's like, I always have Steve Gadd cymbals in James's vocal mic, and he used to use high-end condensers because he loves that sound quality, and now he's been on the KSM8 for 6 months and loves the isolation he gets, but without sacrificing that condenser-like sound that he loves. So it really is it's the best cardioid mic. I mean, that's the real graph. So,
well, and that's another thing again when you're talking about comparing microphones, right? Is that anybody when they just say they have a cardioid pattern microphone will show you just that basic sort of upside down heart shape. Say, look, it's cardioid, but you have to be able to look at it like you see it here at different frequencies and see, does it hold that cardioid pattern or hypercardioid or supercardioid, whatever it happens to be. At how many different frequencies does it still maintain that pattern? Because, if it's really erratic at some frequencies and not at others, that's, again, what leads to that sort of colored off-axis response. But if it's consistent like this, that's the sign of a consistent pattern across frequencies, not just at one frequency.
So we're going to take a quick look in the rest of the features of the KSM8. There's a lot of stuff in this mic that's new. Well, everything is. But first off, the grill. The grill design is totally new. It's a hardened steel grill, so it'll resist denting. Has a little harken back to the 55 design with the badge there. But we actually had to figure out a way to get good plosive protection on this mic, but we physically didn't have any space in the grill. So it's actually, the grill is lined with a hydrophobic woven cloth. And it reduces plosives very, very well. It takes up virtually no space. There's a tiny little piece of foam in the top just for manufacturability of it. But it's glued to the inside, and it basically makes the grill and microphone waterproof. We don't have any sort of IPX certification or rating on it, but we put it under a shower head for 30 minutes. We shook it off. We ran it in the anechoic chamber, and it was totally fine. So it's by far the most waterproof dynamic mic we've ever done. And that's a combination of the grill design, having that cloth in there, and because that second diaphragm seals the entire system, there's physically no entry point for water to get into the microphone. So there's nothing for it to, water can't get in and fill any cavities up with anything. So we have a patent pending design on this particular part. This is called DSS, Diaphragm Stabilization System. Basically, we're using the thinnest diaphragm we've ever used in a dynamic mic because we want the most amount of low end. So you have to make things thinner and more compliant to get there. And in that process, we had to destabilize the diaphragm to keep it from rocking in an unwanted motion. So we designed this new stabilization system. It gets glued to the top of the dome of the actual front diaphragm, and basically reduces high frequency handling noise and keeps the system moving axially in the response that we want it to. Completely new engine, as you will, quote unquote. There's a diaphragm with the coil. We use a new aerospace pole piece material called soft mag. It's a very lightweight, very ferrous metal that they use in the aerospace industry. And most of the time, the pole piece that we talk about, which directs that magnetic field, is just made out of steel. We had to hit a certain weight on the cartridge for durability, and we had to borrow this from the aerospace industry. And it gives us actually more saturation of the magnetic circuit, and then that second diaphragm is there passively to control that proximity effect, and we'll talk about how that is in the next slide. We had to develop an entirely new welding process, so we actually laser weld these two cartridge parts together from the inside out. And there's these little prongs that come in and weld each of these tube systems. These are filled with air, and that's how the airflow routes around the microphone. It survives ridiculous amounts of torture, actually. It was a completely new to the world laser welding process. We couldn't laser weld it from the outside because of the geometry, so we had to laser weld it from the inside, and these little mirrors shine this laser and seam the two parts together in each of those tubes, which was a totally new thing for us and our supplier. And then there's a pneumatic shock mount in this microphone as well. It's a completely different design in terms of implementation, but it's based on the pneumatic shock mount theory of the SM58. So real quickly, we're going to show how the airflow works. So we had to reverse the flow of the airflow of the KSM8 to fit the second diaphragm in there. So sound coming from behind the mic passes through that second diaphragm, and that then sound strike goes up and strikes the front diaphragm. That creates that rejection. But then we need to kind of reconnect everything back together, the cavities of air and the resistance parts, and that's where this tube system comes into play. So we had to reverse the flow of that dynamic mic, so it passes through that second diaphragm, hits the front diaphragm, and then goes back down through this tube system into the pneumatic shock mount. And that reversed airflow is what we patented, and that second diaphragm, the presence of that second diaphragm in that network, at high frequencies, that diaphragm doesn't even exist. Sound passes through it. But at low frequencies, that's where it starts partially blocking low frequencies from building up as you start getting closer to the microphone. So it does it just enough to notice it, and it works really well. It does. So we're pretty excited to finally share this new technology with you guys. So. We built a lot of microphones. These are some of the early transducer prototypes that we made. We built a lot of microphones, and many of them did not work. But you have to build a lot to fix a lot and to keep going and going and going. So we're pretty cool. The mic lab here is pretty cool because they use kind of both really new, innovative simulation modeling, along with just let's slap it together and with some 3D printed parts and some glue and see if we can get some good sound coming out of something. You breathe on it the wrong way, it'll break, but we might have to dink out a piece of cardboard and a whole bunch of super glue and some rubber bands and a syringe maybe. But that's what you do to prototype, you know. And we have all the tools necessary here in the building to do all that, which is really cool. So it's available in wired and wireless, and we actually brought a new finish to the world, a brushed nickel finish. So you can order the KSM8 in a black or brushed nickel, and it's very beautiful. And it's also, we carried that finish over into our wireless transmitters. So you can get a black transmitter on Accent, UHFR, ULXD, and QLXD. And then we actually have new finishes of the brushed nickel finish on UHFR and ULXD. And I believe that will be used tonight on the Grammys as the host mic. So that's exciting. So you can check it out tonight on the Grammys. And then if you have an existing wireless system, pick up the RPW 174, the wireless capsule. If you want to upgrade your existing wireless system, it'll be backwards compatible with any interchangeable wireless system that we have made to date. So that's what's available. It is available now, which is also very exciting to say. If you can get it, we're kind of selling out of them pretty quickly, actually. But that's what's available from yours truly. We already had I'll probably just cover the pricing in the U.S. The price point on the wired is $499. It's a top tier dynamic mic, but it's pretty special. And the wireless capsule goes for about the same price, so it's about $500 for a wireless head as well. So depending on what transmitter you buy it on, you know it will be anywhere from, it'll be varying prices if you buy it with a transmitter.
Great.
Now I think we're ready for questions.
We are ready for questions, and we've got some good ones. So let's start here at the top. Would not all dynamic mics be transformer coupled, and can that transformer be overloaded?
Not all dynamic microphones have a transformer in them.
That is correct.
SM58 does, obviously, but they don't all necessarily do.
Yeah, the transformer can kind of fixes, quote unquote, some things. It just depends on how the microphone is designed. The transformer will up your impedance, or depending on if it's a step-up transformer, it will up your impedance and it will up your signal level as well. The SM58, so what's coming off the coil, the impedance is low enough and the output level is low enough where we include a transformer on an SM58, a step-up transformer. And that basically steps up the level, but while it does that, it also steps up the impedance. But it's low enough at the coil level to be usable still. So it still lands like 290 ohms, which is still considered low impedance.
The original Unidynes had transformers with multiple impedance settings too, so that was one reason to have those in there too.
Yep.
So you could select high, medium, or low impedance.
Yep.
Which low impedance was really low at the time. I think what we called medium impedance back then is actually what you'd consider low impedance now, but that was another reason for those.
Yeah, we went through a transformer study in the beginning of this project of do we want a transformer, do we not want a transformer. We did some listening shootouts with various transformers, high-end, low-end, and we said the transformer didn't bring us any real benefits, so we basically put more turns on our coil and got more output level, and basically it's a transformerless design. It also helped aid in making a wireless version a lot easier because all the parts are identical at that point.
Great. Okay, sort of a use case question here. This one person is using another mic that picks up his guitar, and it sounds really bad when he has his harmonizer on. Are you going to have the same sort of effects with the KSM8, or?
Is this a good thing or a bad thing?
I think that's a bad thing.
Yeah,
it's a problem he's having.
So, yeah, that probably has to do with just that harmonizer is probably creating enhanced frequency response at kind of probably a bad frequency for that mic. The off-axis rejection is extremely clean on the KSM8, so things that come in off-axis on this microphone sound like they're themselves. Mm-hmm. So, there's a lot of products out there that might actually, at 5K, might go super cardio or to bidirectional, or at 100 hertz might be totally omni, so it's it just depends on, that's where that quality of bleed off axis is just as important as what it sounds like on axis, because you don't want bad sounding things bleeding into your microphone. So I would say give it a shot.
Well, didn't you say earlier that you're starting to get some feedback from people that the KSM8 is their new favorite guitar amp mic now?
Yeah. And for the versatility of this mic and all these benefits we talked about with the big sweet spot and smooth top end and textbook cardioid polar pattern kind of translate into a lot of different situations other than just vocal mics. And I've had a couple heavy-hitting users say this is my new guitar amp mic. So Dancing with the Stars broadcast mixer he says it's by far my guitar amp mic of choice going forward. And I just got another text message yesterday from somebody who mixes the NFL honors and said, I was amazed at how good it sounded on guitar amps. So I've had reports of it using as a kick drum mic with great success. I use it as a horn microphone for trumpet and saxophone on jazz bands, because that huge sweet spot as a section mic, you don't have the ability to go up and place a mic in a big band section, so you rely on the director or the artist to move the mic for you. And having that huge sweet spot and having that clarity off axis, even if they are pointed into the side of the mic, it's super forgiving and still great low end. And so I think this microphone will not only be a great vocal mic, but arguably an awesome instrument microphone as well.
Great. Okay, in terms of the shock mount in the SM58 or in the KSM8, how much does it reduce noise in terms of decibels?
Very good question. It changes based on frequency, but we test below 400 hertz in our vibration tests, and from basically 20 to 400. From a decibel standpoint, depending on the tune-up, it can be, I think at minimum it's 10 dB is our threshold, but it takes into account the sensitivity of the microphone, and but it's significant enough. We have some measurements where we don't like to go below or above, if you will. And we have some thresholds in place in the production line, and we test each microphone's shock mount individually on the production line. So I think at minimum it's 10 dB, and could even be as far as 20 dB of reduction in handling noise.
Great. Okay, sorry.
That's a hard thing to calculate because of handling noise is such a the stimulus of handling noise is such a variable thing. So taking in the G
hitting
force,
the microphone this hard,
or just grabbing it or snapping it into a clip. So it varies based on the impulse of the source.
Great. Okay. Here's a fun one. I've always told people that you can use an SM58 to hammer nails into wood and it will work beautifully. Does the KSM8 have the same kind of ruggedness?
Yes, it does.
We decided it was even more rugged.
It is. The KSM8 is pretty special. It has actually passed some pretty intensive, highly accelerated life tests that we put this mic through. They are by no means used for production or simulation, but we have a halt chamber here, which is a highly accelerated life test, and basically shakes the microphone at 60 Gs while changing the temperature from like 200 Fahrenheit to negative 100 Fahrenheit in like 10 seconds.
Sounds like the world's worst amusement park
ride.
Yeah,
it's a pretty nasty test, and the test is not meant. You're not meant to pass this test. You're meant to
see how long
extreme test to see what fails first. For instance, we put UHFR racks in here, a long time ago, and when you have that expansion and contraction of components so quickly because of the temperature shock, you find out that, hey, the little ribbon cable pulled out, and we need to make the ribbon cable another 1/4 of an inch longer so it doesn't pull out. You find things like that. Mm-hmm. The KSM8 was not supposed to pass this test, and it actually passed. The SM58 did not pass it. It kind of melted. But the KSM8 passed it, and it was pretty surprising. Half the battle is it's the test itself, passing its own test, because it breaks itself every time you run it, basically. So, but yeah, the KSM8, without a doubt, is just as rugged, if not more rugged, than an SM58. And I'm pretty confident in saying that, which is a high claim.
That is a high claim. Okay, somebody here that says they used it this past week with a diva. Oh, those divas. And he was totally blown away with the product, but there was a slight problem with plosives. Do you think that was a technique issue or?
Yeah, the plosives are always an issue on any mic. And we do have the cloth in the grill. We have foam in the grill. We do have more low end in the response of this mic than other dynamic mics. So we measured about the same plosive response as an SM58. It actually was a hair better at 100 hertz. So I think the plosive is a tough thing to manage because it's basically the only way to really combat plosives is space, get more space between the grill and the element, and you don't have that much space inside there. So I think low cut filters will always help on plosives, and all the testing I've done and have heard from the field is it's not any worse than anything else out there, especially from our portfolio, and maybe in some cases better depending on the artist.
Great. Okay, are there any SPL limitations with the dual diaphragm design?
No, this is still a dynamic mic at its heart. So you can't really clip a dynamic mic, if you will, or overload a dynamic mic.
Not with any sound a human can make.
Not with any sound, really, any human can make, exactly.
Any musical instrument or otherwise.
Yeah, there's no max SPL on this mic. There's no self noise on this mic because there's no circuitry. So, for you to overload a dynamic microphone, you pretty much have to bottom out the diaphragm in the pole piece, and that just physically can't happen with
You'd have
the
to,
sound source.
What do we say? Have to mic the space shuttle taking off at close range.
Yeah, like 3 inches to like bottom out, have that much sound pressure. So
okay, how is the proximity effect compromised when you get someone who cups the mic with the new Dualdyne design?
Cupping the mic, yeah, that's a challenge. That came up a lot because it's a big issue for many users now. Is when an artist cups the mic, it changes, and I've had kind of a mixed bag of reports from users on the cuppability, if you will, of this microphone. Because there is more low end response in the mic, it doesn't honk out, quote unquote, as quickly as like an SM58 will. So it does change though. It's not immune to cupping, but I would say the change you do get is lessened with the KSM8 than some other products. For those of you who really want a cuppable mic, I would highly suggest the KSM9 HS in hypercardioid. The KSM9 HS is a hypercardioid dual diaphragm condenser, and it is extremely stable when it's cupped. It changes minimally, if at all. So the KSM9 HS and hypercardioid is my suggestion for anybody who wants a mic where you can cup and it doesn't change.
Okay. What is the sensitivity of the KSM8 as compared to the SM58 and the Beta 58? And is it already using neodymium magnets, or will we see a beta version in the future?
That's a good question. Sensitivity is 51.5, which is a half a dB shy of a Beta 58. And it's about 5 dB hotter than an SM58. So it is a neodymium magnet. It does have a new pole piece to kind of harness as much of that magnetic energy as we can. In terms of the beta-ness of it, it is a cardioid. It's not a super cardioid mic, the KSM8. So, but it does have a hardened grill like many of the Beta products do, and it has a nice hot output like the Beta products do, and about 5 dB hotter than an SM58.
What's the weight difference between an SM58 and a KSM8?
Man, you guys are testing my specifications.
There's a lot of good questions here, and we are not even close to being done.
The SM58's weight, do not quote me on this, but I think the SM58's weight is around 300 grams. The KSM8 is 330 grams, so just about the same weight as an SM58. And you know what's funny? At the NAMM show, when you look at the brushed nickel and you look at the black, everyone thought that the brushed nickel, when they picked it up, was light, and everyone thought that when they picked up the black, was nice and heavy. Even though they're identical weights, because of the metalness of the brushed nickel, they expect it to be this big, heavy thing, and it feels really good in your hand. It's a very well-balanced, very nice, solid feeling mic.
Okay. Does the interaction between the two diaphragms happen electrically or acoustically? Does each have its own magnet and coil, or is the second diaphragm causing an acoustic change that the first diaphragm sees?
It would be the latter. It's not electrically hooked up. The second diaphragm is just passive. It's the presence of the second diaphragm in the acoustic
And it has
network.
no coil.
And it has no coil. It has no magnet attached to it. It's a single element design. But the side entry network, how sound strikes the back of the microphone to create that rejection, that second diaphragm is part of that resistance network. So it is in conjunction with the resistance part that's inside the mic that sets the polar pattern and the tune-up. And the physicality of having that diaphragm as part of that of that network, acoustic network, it basically tricks the front diaphragm, the one that is hooked up to a coil and a magnet, to think it's kind of omnidirectional. But only at low frequencies. But we do that in a way where it is not omnidirectional. It's still fully cardioid down at 250 hertz, as you saw, but kind of tricks it into thinking it's omnidirectional at low frequencies, and omnidirectional mics don't have proximity effects. So it's kind of a little bit of trickery of the interaction of the presence of that second diaphragm on the front diaphragm.
Great. All right. Well, unfortunately, we still have a ton of questions, but we are out of time. So we're going to have to close it up for the day. But if you have any of these questions that are just burning a hole in your brain, please feel free to send a message to support@shure.com, and we will answer those in due time. Our guys are pretty quick about that. But we want to thank you so much for joining us today. We hope you learned a little bit, and we will see you next time.